uniform gradient annual equivalent amount. In this type of investment mode, the objective is to determine the equivalent amount A of a series with an amount A1 at the end of first year and with an equal increment G at the end of each of the following n-1 years at an interest rate I compounded every period. The cash flow diagram of this investment is, we have a time scale. At the end of first year, there is an investment of A1. At the end of second year, there is an investment of A1 plus an annual increment of G. At the end of third year, there is an investment of amount A1 plus 2 times G. At the end of fourth year, there is an investment of A1 plus 3 times the annual increment G. Similarly, at the end of n-first year, the investment will be A1 plus n-2 G. At the end of nth year, the investment will be A1 plus n-1 G. The mathematical representation of this statement is A1 plus G, which is the known value, with unknown A and I interest rate and n interest period. The factor A slash G I n is called uniform gradient series factor. The formula to obtain the annual equivalent of a uniform gradient series is A is equal to A1 plus G multiplied by 1 plus I to the power of n minus I into n minus 1 all divided by I into 1 plus I to the power of n minus I. Here the value of I is in terms of decimals.
Let's now consider an example for uniform gradient series annual equivalent amount. Determine the annual equivalent if a person wishes to invest rupees 15,000 at the end of first year and thereafter he wishes to deposit the same amount with an annual increment of rupees 2,000 for 7 years with an interest rate of 18% compounded annually. So in this particular question, we are supposed to determine the annual equivalent of this particular investment. What is that investment? In the first year, he wants to deposit 15,000. In the second year, he wants to deposit 15,000 plus 2,000. In the third year, he is going to deposit 15,000 plus 2 times the 2,000. That is the annual increment of 2,000 again. And he keeps on adding this particular annual increment up to 7 years. So now we are supposed to determine what will be the annual equivalent of this uniform gradient series. So we'll solve it. We'll write down the given data. So initial investment. That is denoted as A1, which is the constant amount, which is equal to rupees 15,000. Next, equivalent increment. equivalent increment, which is denoted as capital G, is rupees 2000. So every year there is an annual equivalent, annual increment. Next, rate of interest or interest rate. Interest rate, which is small I. The rate of interest is 18%, so it is 18%. Into decimals I am going to convert 0.18. Now interest period. Interest period n, which is equal to. Now we are supposed to be careful. What is the value of interest period? Now there is a lot of confusions with respect to taking interest period as 7 years. But interest period is not 7 years because it is the annual increment of 7 years. But the investment in the first year, there is no annual increment. So in the first year it is just 15,000. From the second year there is an annual increment of 7 years. Therefore the interest period will be initial investment year plus annual increment years, which is equal to, so initial investment is at the first year plus there are 7 annual increment years, so it is 7 annual increment years. So totally the value of n is equal to 8. So this particular thing is very important. Kindly don't get confused and take the interest period as 7 years, because this is just the annual increment of 2000 for 7 years. But before this annual increment there is a 1 year investment of 15,000. Therefore 7 years of annual increment plus 1 year of initial investment. So the total investment period will be 8 years. The cash flow diagram for this problem will be, you have a time scale, you have the cash inflow, you have the cash outflow. Now the value of n for our problem is 8 years. So I will draw a time scale with 8 years. Starting with 0, 1, 2, 3, 4, 5, 6, 7 and 8. Now at the end of first year the investment is 15,000. Then from the second year onwards till 8th year the person is going to invest the initial investment plus 2000 of annual increment. So that is, for the second year it will be 15,000 plus 2000. Next, for the third year it will be 15,000 plus 2 times 2000. Next, for the fourth year it will be 15,000 plus 3 times 2000. So first annual increment, second annual increment, third annual increment, and it goes on. For the 8th year it will be 15,000 plus, you can see here, for second year it is just 2000, third year it is 2 times of 2000, fourth year it is 3 times the 2000. So for each year whatever you consider, the increment will be 1 less than that particular year. So you can see here, for second year it is just 2000, third year it is 2 times the 2000, that is 1 less than the year. Therefore for 8th year it will be 7 times the 2000. And you have this year also, you have the investment. So same time it is going to increase. So this is the cash flow diagram for this particular problem. Now we'll calculate what is the annual equivalent. Annual equivalent which is denoted as A, that is the annuity, is given by A1, which is the initial investment, plus G, that is the equivalent increment or the annual increment, multiplied by, this is quite a big equation, 1 plus I to the power of n minus in minus 1 whole thing divided by I into 1 plus I to the power of n minus I. It is quite a big equation to remember, so there is no other option. You are supposed to memorize it. Now I am going to substitute the values into this particular equation. So I'll write it from this end because it is quite a big equation, which is equal to A is equal to A1 is 15,000 plus G is 2000 multiplied by 1 plus I is 18%, 0.18 to the power of n is 8 minus I into n, so I is 0.18 multiplied by 8 minus 1 whole thing divided by I 0.18 multiplied by 1 plus 0.18 to the power of n, which is 8 minus I 0.18. So this is the equation, is equal to 15,000 plus 2,000 multiplied by, we'll calculate what is the value of this whole equation. Okay, 1 plus 0.18 to the power of 8 minus 0.18 multiplied by 8 minus 1. This divided by 0.18 multiplied by 1 plus 0.18 to the power of 8 minus 0.18. This gives us 2.658. So I'll consider it as 2.656. So this value is 2.656, which gives us the annual equivalent of 15,000 plus 2,000 multiplied by 2.656. 15,000 plus 2,000 multiplied by 2.656 will give us annual equivalent of rupees 20,312. So for the investment of 15,000 at the end of first year plus 2,000 annual increment for next 7 years along with the initial investment and bank giving an interest rate of 18% will lead to an annual equivalent of rupees 20,312 rupees. Now let's solve one more problem on uniform gradient series. Sushma plans for a retirement 10 years from now. So she wishes to deposit rupees 40,000 at the end of first year, and thereafter she wishes to deposit the same amount with an annual increment of rupees 5,000 for next 9 years with an interest rate of 12.25% per annum. Find the total amount she will be left with at the end of 10th year. So very interesting question, just like the previous problem. So here the Sushma wishes to deposit rupees 40,000 at the end of first year. Then from the second year she wishes to deposit this 40,000 plus an annual increment of rupees 5,000 for next 9 years. Now I think you will have an idea of the value of N, that is the investment period. So investment period will be first years of 40,000 plus 9 years of 9 incremental annual increment of 5,000. Therefore the total investment period will be 1 plus 9, which is 10. For this the bank is going to give her 12.25% of interest. Now in this particular problem we are supposed to determine what will be the total amount she will be having at the end of 10th year. So we are supposed to calculate what is the future value of the investment made by Sushma at the end of 10 years. So let's solve this particular problem. So given data, initial investment, that is A1 is equal to rupees 40,000. Next, annual increment, it is capital G, is equal to rupees 5,000. So every year there will be an annual increment. Interest rate, which is I, is equal to 12.25%. So if I convert it into decimal, it will be 0.1225. 12.25 divided by 100. Now interest period, that is N, is equal to initial investment year plus number of annual increment, so which is equal to the first investment period plus 9 annual increment. Therefore value of N is 10 years. The other clue what they have given is in the question itself. So in the first statement only they have given Sushma plans for a retirement 10 years from now, and the second clue they have given is what is the total amount shall be left after 10 years. They have already given 2 clues regarding the value of N. Now we will draw the cash flow diagram for this particular problem. So you have the timeline, so cash outflow, then you have the cash inflow. Now she is wishing to deposit the money into the bank account, therefore she is investing the money from her account into the bank account, that is the cash outflow, and this is happening for 10 years. So I don't want to draw the complete 10-year timeline, so I'll just draw for few years. So at the end of first year she is depositing 40,000. At the end of second year it will be 40,000 plus 5,000 increment. At the end of third year it is 40,000 plus 2 times the 5,000. At the end of ninth year, now I think you'll get an idea, it is 40,000 plus, so the term which you are going to multiply will be 1 less than the year which you are going to consider. So for second year it is 1 time 5,000. For third year it is 2 times 5,000. For ninth year it will be 8 times the 5,000, and for the 10th year it will be 40,000 plus 9 times the 5,000. So this is the cash flow diagram for this particular problem. Now we'll put the equation and determine what is the annual equivalent and what is the total amount we'll be having at the end of 10th year. Now we have annual equivalent. Annual equivalent, that is annuity, is given by A1 plus G into 1 plus I to the power of n minus in minus 1 whole thing divided by I into 1 plus I to the power of n minus I. Now I'll substitute the values into this particular equation. That is A is equal to A1 is 40,000 plus G is 5,000 multiplied by 1 plus I is 0.1225, 12.25%, to the power of n is 10 minus 0.1225 multiplied by 10 minus 1 whole thing divided by 0.1225 multiplied by 1 plus 0.1225 to the power of 10 minus 0.1225. That's quite a big number to multiply. So which gives us 40,000 plus 5,000 into, so put this equation in calculator and we can determine the value of this is 3.57. So if I multiply the whole term, the annual equivalent is rupees 57,850. So by converting the investment of Sushma, that is the initial deposit of 40,000 and thereon for next 9 years, and investment of 5,000 will give us an annual equivalent of rupees 57,850 rupees. Now the question they have asked, what is the total amount Sushma will be having at the end of 10th year? So the question, the second part of this particular question is total amount Sushma is going to have at the end of 10th year. So this is what we are supposed to determine. So for this what Sushma is going to have in the future, that is the value of F, that is the future amount of Sushma is equal to, we know what is the value of annual equivalent, that is annuity. Now this question is the future value of annuity, or the compound amount of annuity, or capitalized cost of annuity, so whatever you can consider. So it is the capitalized amount of your annuity. So F is equal to A into 1 plus I to the power of n minus 1 divided by I. So what the amount Sushma is going to have at the end of 10th year is nothing but the compounded amount of annuity. So we know the value of annuity as 57,850 multiplied by 1 plus I is 0.1225 to the power of 10 minus 1 whole thing divided by 0.1225. So I'll calculate the value of this particular term. So it is 57,850 multiplied by, so the value of this term is 17.76, which I'm going to get it as rupees 10,27,416. So for the investment made by Sushma, she is going to have a total amount of rupees 10,27,416 rupees at the end of 10th year. So this is the solution of this particular problem.